The universe does not care what we wish were true. Isaac Newton could not make peace with that. He wanted certainty in a world built from change, and he was willing to pay for it with loneliness. One question follows him like a shadow. Why does an apple fall, but the moon does not? The answer is not poetic, it is exact. The moon is falling too, it just keeps missing Earth. That is the doorway into Newton's life. Not a lightning strike, but a long refusal to stop asking. The apple story is a symbol, not a time stamp. The real beginning is an orbit forming inside his imagination. Before there were laws, there was a boy learning to endure. It begins far from applause. It begins with survival. He was born on Christmas Day, 1642 by England's old-style calendar, or January 4th, 1643 by the Gregorian modern calendar. He was a tiny, fragile baby, and people did not expect him to survive. Even his first day was an argument he had to win. His father died before he was born. His early home life shifted, and stability kept changing its shape. When his mother remarried, he was left at Woolsthorpe in his grandmother's care for years. Children learn quickly what absence feels like when it arrives in a familiar voice. He grew into someone who watched more than he spoke. The world became safer when it could be studied from a distance. He built small mechanisms and careful models. Even then, his hands seemed to trust rules more than reassurance. In the countryside, nature is direct. Wind does not flatter, and weather does not bargain. Newton learned the comfort of that honesty. If something moves, something caused it. At school, he was not yet a legend. He was simply stubborn, sharp, and hard to distract. His mind learned a rare skill. It learned to stay with a question after others had abandoned it. His quiet mind finally meets a library big enough to hurt. He finds more answers here, and even more reasons to doubt old ones. In 1661, Newton entered Trinity College, Cambridge. He arrived with limited money and endless curiosity. He studied what was required. Then he studied what he could not ignore. Some people read to finish a course. Newton read to scrape truth down to bedrock. In his notebooks, geometry becomes a private language. Motion becomes a problem he cannot put down. He starts building tools he will need later. He needs a way to calculate change without guessing. He also begins to notice something unsettling. Confident explanations can be elegant and still incomplete. It is one thing to respect authority, it is another to let it do your thinking. Newton was not a gentle personality. He was private, intense, and easily stung by criticism. Keep that human detail in frame. A luminous mind can still feel exposed. And when he feels exposed, he grips harder. That will matter later. The world shuts its doors, and Newton opens his own. What looks like interruption becomes acceleration. In 1665, plague emptied Cambridge, and Newton was sent back to Woolsthorpe. He stayed until March 1667, with only a brief return to Cambridge cut short when the plague returned. The world slowed down. His thoughts did the opposite. Without lectures and schedules, he built his own. A mind can become a laboratory if it refuses rest. He studies how objects fall. He studies how bodies move when pushed, pulled, or left alone. He also turns to light. A beam through a prism becomes an argument with reality. In a darkened room, he splits white light into color. He shows that whiteness is layered, not simple. This is not just a clever trick. It is a warning that obvious is often inherited. The miracle of these years is not speed alone. It is focus that survives boredom and doubt. If genius has a sound, it is not thunder. It is the steady scratch of a pen that keeps going. And somewhere in this quiet, the gravity question sharpens. If Earth pulls the apple, might Earth also pull the moon? He does not treat it as a bedtime story. He treats it as a problem that must answer back. He does not need a legend to begin. He needs a question that refuses to leave. He cannot tame motion with old tools, so he builds new ones. He makes mathematics keep up with reality. Motion is not only where you are, it is how you are changing, moment by moment. Newton develops methods to handle change with precision. Today we call much of it calculus. To him, it is a tool, not a trophy. First, you build the instrument, then you play the music. With this, he can describe acceleration without hand-waving. He can capture turning points in a curve and keep them on the page. It is hard work, done mostly alone. Many world-changing ideas begin as private scaffolding. This matters for more than mathematics. It gives him a language for orbits, forces, and prediction. He's preparing for the sky, he just does not announce it yet. He is building the ladder in silence. Later, the world will see how high it reaches. Theory becomes hardware, and the hardware works. A bright idea turns into a real object you can hold. His prism results upset people who preferred older explanations. Newton had found that color belongs to light itself. When a lens blurs colors, he does not accept the blur. He changes the method. He designs a reflecting telescope that avoids much of that distortion. It is compact, practical, and quietly brilliant. He presents his work to the Royal Society. Praise arrives, and so do pointed questions. Newton often hears questions as threats. It is a flaw, and also part of his engine. He argues, sometimes fiercely. In fairness, his results hold up. Being correct can make a person careless with people. Newton was not always careful, and the same intensity that builds a telescope can also build an enemy. That will matter later too. The private thinker is pushed into public reality. The ideas leave the notebook and they do not come back. In 1684, Edmund Halley comes to Newton with a question about planetary paths. Halley is not only curious, he is persistent. Newton responds with a proof. The proof grows into a manuscript, and the manuscript becomes a book. Halley shepherds it into print. The world owes him a quiet thank you for not letting it stay in a drawer. Picture the scene shift. Ink, candlelight, and pages packed with diagrams. This is not a romantic montage. It is craft, revision, and relentless checking. In 1687, the Principia is published. It is so dense that it feels heavy in the hands. If you ever wondered what intellectual gravity looks like, it looks like a book that refuses to be skimmed. Inside it are 3 laws of motion. They are simple to state and enormous in reach. 1. A body stays at rest or in straight-line motion unless acted upon. 2. A change in a body's motion is proportional to the force impressed along the line it acts. 3. Every action meets an equal and opposite reaction. 3 short rules, and suddenly the world becomes calculable. Then comes universal gravitation. Newton argues that every mass attracts every other mass. Now the apple and the moon belong to the same sentence. The orchard and the cosmos become neighbors. Here is the payoff to the opening question. The moon falls, and its missing is the shape of an orbit. Newton did not merely explain falling. He explained how falling can become a path. And once you see that, the sky stops being a mystery. It becomes a system you can test and trust and to build upon. Success does not soften him, it tightens his grip. But even triumph has a price. The higher he rises, the more fiercely he guards his ground. The more his ideas spread, the more he fears being diminished. Insecurity can survive even perfect proofs. There are conflicts with other thinkers, including Robert Hooke. Some disputes are about ideas, and some are about credit. But arguments leave rooms. Coffeehouses buzz, letters fly, and whispers carry the dispute beyond either man's control. It is easy to imagine science as serene. In reality, it is done by humans with human nerves. Later comes the calculus priority dispute with Gottfried Wilhelm Leibniz. Many historians conclude both men developed key ideas independently. What matters here is not a scoreboard. It is the reminder that brilliance does not immunize anyone against ego. Newton could be generous with truth. He could be less generous with rivals. He also shows signs of strain in this period. Even a towering mind can bend under pressure. It is easy to admire genius from a distance. It is more honest to notice the cost of carrying it. Newton's life is not a fairy tale. It is endurance with consequences. And the costs are not just personal. They ripple into the way history gets told. The theorist then steps into a city that runs on metal and trust. He trades celestial order for civic order. In 1696, Newton takes a role at the Royal Mint in London as warden. It surprises people who keep him trapped in an orchard myth. He helps oversee a major recoinage effort, and he pursues counterfeiters with serious focus. In 1699, he becomes master of the mint. The man who measured the heavens now measures money with the same attention. Imagine the shift, from silence and solitude to heavy presses, metal blanks, and the clatter of work. Newton's mind does not change gears slowly. When he decides something is a problem, it tends to stay solved. It is a different kind of force. It is force applied to a system that has to hold. The legend gains an office, and the man stays complicated. Public honor arrives, and private habits remain. In 1703, Newton becomes president of the Royal Society. By then, he is not only a thinker, he is an institution. Symbols are heavy things to carry. Newton carries it, often without looking like he enjoys it. In 1704, he publishes Optics, a clearer and more experimental work than the Principia. It spreads widely and shapes how people do science. His interests were wider than the tidy classroom story. He spent years on private studies in alchemy and religious texts, searching for hidden order. This does not weaken his legacy, it strengthens the human picture of a man built for pattern. He never married. He kept his inner life largely sealed. It is tempting to romanticize that isolation. It is better to see it as a trade, sometimes chosen, sometimes endured. In 1705, he is knighted. Sir Isaac becomes a symbol of intellect itself. History loves a clean statue. Real lives are rarely clean. And the cleanest statues often hide the most complicated rooms. The rules outlast the person, and that is the strange beauty of them. The man ends, and the method stays. Newton dies in 1727. By then, he has reshaped how humans explain motion and the sky. His laws become the backbone of engineering, navigation, and eventually spaceflight. For centuries, if something moved, Newton's sentences moved with it. Later thinkers would extend and revise the framework. That is not a failure, it is the point of a framework. A great theory does not end curiosity. It gives curiosity a stronger spine. Newton's deeper gift is not a single equation. It is discipline, a refusal to let mystery become laziness. He made nature answerable to experiment and mathematics. He taught the modern world to ask questions that can be tested and still keep the man in frame. Private, proud, brilliant, and sometimes brittle. He shows that greatness is not the absence of flaws. It is the endurance to keep building anyway. If you ever wonder what kind of power lasts, look here. Quiet attention can outlive empires because it writes the rules that empires still obey. From a lonely question in a small farmhouse to laws that still steer our machines and moons, patience became power. You're always welcome here. And remember, it's Illumentary.